Hello, welcome to everyone in this video. Today we want to discuss about the question which asked in the physics honors Calcutta University previous year question 2022. Already we discussed this question number 1 in previous lecture, and today we want to discuss question number 2 and question number 3. And upcoming session we will be continue this question number 4, 5, 6 and 7, right? So at first you try to solve this question, after that continue the video was the solution. First question says, in a region of space the electrostatic field is everywhere directed parallel to x-axis, that is the direction of the electric field along the x-axis, that is I cap, so that the field in this region is independent of y and z coordinate. So this is given, that is the electric field which is directed along x-axis. So the magnitude of the value is can be function which is also which can be function of x. So just put this value E, which is have a 3 coordinate, that is Ex and Ey, Ez are 0. There is no component along the y direction and the z direction. So finally you can write that Ex 0 0. So taking the curl, that is I cap del y of 0, del z of 0, then j cap del x of 0, del z of Ex, and then k cap del x of 0 and del y of Ex 0. Del Ex del z 0, del Ex del y 0, that is there is no component of z, no variation of z on Ex and no variation of y and in Ex. So Ex is independent of y coordinate and z coordinate, that is Ex only function of x. So I think clear about the answer. Next, further, if there is no charge in this region, prove that field is also independent of x. If there is no charge, then by Gauss theorem you can write easily right hand side 0, so E must be 0. Hence the field is independent of x also. Next question says 12 equal charge are situated at the each numerical of clock face. So there is 12 equal charge situated at the each point of a clock. What is the net force on the test charge Q on the center? If there is a test charge capital Q, then what is the force? You can see the force on this charge due to this charge at the 6 along the that direction, if these two are positive, and for 12 along the that direction. So since these two are charged equal, you can see the force value will be like that, 1 by 4 pi epsilon naught q by distance square, if this distance is d or if distance is r, so r square. Since these two force equal and opposite, so you can easily cancel out. Similarly for 1 7 2 8 3 9 are all are cancel out to each other. Finally net force on this charge will be 0. Net force on the charge will be 0. Is written here, if there are 12 equal charge situated on the each numerical clock face, a test charge Q the center, then each opposite face on Q will cancel out and force will be 0. Okay. Next question. Use Gauss theorem to prove following statement, that is a closed hollow conductor shield its interior from fields due to charge outside, but does not shield exterior from the field due to charge placed inside it. That is, when charge is outside, then you can take the Gauss surface inside the sphere, then you can easily by Gauss theorem enclosed charge is 0. By Gauss theorem you know the closed integration of E dot ds, that is the surface integration of the electric field, must be equal to enclosed charge by epsilon naught, right? Since there is no charge within this sphere, within this surface, so you can see there is right hand side 0, so E inside E in is 0, right? In case of outside, that is charge within this surface, Gauss surface, so this charge will be like that. So in the interior the electric field 0, but when the exterior there is a field due to this charge. Next question says an electric dipole formed by two equal and opposite charges. Electric dipole made of equal and opposite charges of magnitude 1 microcoulomb separated by a distance 1 meter. So there is two charges separated by 1 meter with the value minus 1 microcoulomb and the plus 1 microcoulomb. And the uniform electric field of strength, this is the electric field with the value, the strength of this electric field is given here is like that 10 to the power 5 volt per meter, 10 to the power 5 volt per meter. You can write clearly that is 10 to the power 5 volt per meter. Work done to rotate the dipole end to end, that is 180 degree. You can see such that the axis on the dipole parallel to field. So parallel to field, this you need to find out the work done to rotate the dipole end to end, that is 180 degree. That is, you need to change this dipole, that is along that direction minus 1 microcoulomb plus 1 microcoulomb. This direction along this is the dipole direction and the direction of along. So you need to change the direction of the dipole in the 180 degree, then what will be the work done? Work done formula is minus P dot E cos theta 2 minus cos theta 1, because you know this torque is tau equals to P cross E, and tau theta work done integration tau d theta. So P is sin theta, P sin theta d theta. So there is a Pe minus P cos theta. So from there you can write minus Pe cos theta 2 minus cos theta 1 if you put the limit. Okay. So theta 2 is pi 180 degree, pi or 180 degree, and this is 0, cos 180 degree minus 1, and this minus 1 minus 2. So finally you will get 0.2 joule, right? Next question says the dielectric constant of monoatomic gas at NTP is 1.000538. So this is the value of K, dielectric constant. Calculate the dipole moment induced in each atom when gas is placed an external electric field 30 kilovolt per meter. So this is the electric field, that is 30 kilovolt per meter. The electric field value is 30 kilovolt per meter. So from the value of K, dielectric constant, you can easily find out the susceptibility chi equals to K minus 1. You know K equals to 1 plus chi. So the value of chi is 0.00538. So the polarization of monoatomic gas, that is P equal to epsilon naught chi E. So put the value here. For that you need for that you need to find out the number of atom per the unit volume, because here the 1 mole, this is the total number, and there is a NTP. So the volume will be 22.4 liter, from liter to meter cube 10 to the minus 3. For liter to meter cube 10 to the minus 3. So this will be 2.7 10 to the minus 25 meter to the minus 3. Hence induced dipole per each atom. This is the number of atoms, so divided by the number of atom. So if you calculating, this will be 5.29 to the minus 36 coulomb into meter. I think you clear. If there is any error, you must comment in the comment box. Next question. A dielectric sphere of radius A, frozen in polarization. This is the polarization within this region, where K is constant, R is the distance from the center, Use Gauss theorem in dielectric, find the electric field inside and outside the sphere. You know from polarization you can find the volume charge density and the surface charge density. Volume charge density minus divergence of P. So if you take divergence in spherical polar coordinate, you will be get minus 3K, which is constant. In surface charge density, you will be get Ka, which is also constant. For inner side, you can use this Gauss theorem. There is no free charge, so this part will be 0, and the polarization charge is charge density into volume. This is the charge density and the small volume. Integrating, you will be get this relation. So from this, you will be get the internal or electric field within the surface, within the sphere. You can say this is the increasing like that. For outside, you can say for total charge is for this one, because inside for inside there is only volume charge density, but outside there are also surface charge density contribution. So for volume charge density and this surface charge density, the area of the surface is 4 pi a square, and this limit will be 0 to a. So you can see easily find out this will be total charge is 0. Since total charge is 0, from Gauss theorem you can easily find out the field external point, field at the external point must be 0. So I think clear about the solution of this question. If there is any doubt, you must comment in the comment box. This is all about me. This is my contact details and this is my YouTube channel. So take care. We'll meet to the next video as soon as possible. Thank you.